Principles of problem solving. There are no hard and fast rules that will ensure success in solving problems. However, it is possible to outline some general steps in the problem solving process and to give some principles that may be useful in the solution of the certain problems. These steps and principles are just common sense made explicit. They have been adapted from George Polya's book, How to Solve It. The first step is to read the problem and make sure that you understand it clearly. Ask yourself the following questions. Number 1, what is unknown? Number 2, what are given quantities? Number 3, what are the given conditions? For many problems, it is useful to draw a diagram and identify the given and required quantities on the diagram. Usually it is necessary to introduce suitable notation, and choosing symbol for the unknown quantities are often used letters such as A, B, C, M, N, X, and Y. But in some cases, it helps to use initials as suggestive symbol. For instance, V for volume and T for time. Find a connection between given information and the unknown that will enable you to calculate the unknown. It often helps to ask yourself explicitly, how can I relate the given to the unknown? If you don't see a connection immediately, the following ideas may be helpful in driving a plan. Try to recognize something familiar. Relate the given situation to previous knowledge. Look at the unknown and try to recall a more familiar problem that has a similar unknown. Try to recognize patterns. Some problems are solved by recognizing that some kind of pattern is occurring. The pattern could be geometric, numerical, or algebraic. If you can see regularity and repetition in a problem, you might be able to guess what the continuing pattern is and then prove it. Use analogy. Try to think of analogous problem. That is a similar problem, a related problem, but one that is easier than the original problem. If you can solve the simpler problem, then it might give you the clues you need to solve the original, more difficult problem. For instance, if a problem involves very large numbers, you can first try a similar problem with smaller numbers. Or if the problem involves three-dimensional geometry, you can look for a similar problem in two-dimensional geometry. Or if the problem you start with is a general one, you could first try a special case, introducing something extra. It may sometimes be necessary to introduce something new, an auxiliary aid, to help make the connection between the given and the unknown. For instance, in a problem where a diagram is useful, the auxiliary aid could be a new line drawn in a diagram. If in a more algebraic problem, it could be a new unknown that is related to the original unknown. Take cases. We may sometimes have to split problem into several cases and give a different argument for each of the cases. For instance, we often have to use this strategy in dealing with absolute value. Work backward. Sometimes it is useful to imagine that your problem is solved and work backward, step by step, until you arrive at the given data. Then you may be able to reverse your step and thereby construct a solution to the original problem. This procedure is commonly used in solving equations. For instance, in solving the equation 3x minus 5 equal to 7, we suppose the x is a number that satisfies this equation and work backward. We add 5 to each side of the equation and then divide each side by 3 to get x equal to 4. Since each of these steps can be reversed, we have solved the problem. establish sub-goals. In a complex problem, it is often useful to set sub-goals in which the desired situation is only partially fulfilled. If we can first reach these sub-goals, then we may be able to build on them to reach our final goal. Indirect reasoning. Sometimes it is appropriate to attack a problem indirectly. And using proof by contradiction to prove the P implies Q, we assume that P is true, Q is false, try to see why this can't happen. Somehow, we have to use this information and arrive at a contradiction to what we absolutely know is true. Mathematical induction and proving statements that involve a positive integer. It is frequently helpful to use the following principle called principle of mathematical induction.